whatever you have. I'll begin with a word of prayer. So, Heavenly Father, we thank you for this day. I thank you again for these students and for this morning. It's time we have to study your creation. Just pray that you'd help us to answer any questions that remain before test 2 for these students, and just to encourage them to just do their best, Lord, each day for your glory. Excuse me. In your name I pray, Lord Jesus. Amen. Oof. I don't know, it's got into me this morning. I guess fog makes me sneeze or something. Okay, so any questions before I get into it? No? So let's see here. Number 1, I think over 100 people took this quiz, right? But no one called me on this right here. This is none of the above, technically speaking. Like, you have to take this formula right here and subtract 4 from it to get that graph. So something got lost in translation there. I should have subtracted 4 in order to actually get the pictured graph. What this graphs to is that. All right, so what would you like your name to be?
Taylor.
Okay. There you go. Mm-hmm. Let's see. Here you go. So, yeah, I'm sorry about that. If that actually caused you to get confused in this problem, then, come see me about it after class or something. But I don't think it actually got anybody, because I think pretty much everybody answered problem 1 just at a surface level, right? And that's actually what I wanted, because these 4 different functions are really different shapes, right? Like, this one is a volcano for sure, right? Because it's got division by 0 and it's got a square downstairs. So I expect to see a volcano from this formula. That's a cubic, so it's going to be like a cube root, like a cubic graph turned sideways. That's what cube roots look like. That's got absolute value, so you're looking for a v, right? And that's got a square root, so you're looking for like half of a parabola turned sideways. So if you understand those kind of surface level conceptual pictures of these, then you can just solve this problem on the basis of that pattern matching, right? But there is a harder version of this problem that I might ask on the test, right? What would make this question harder? What if instead of 4 different graphs, I had 4 parabolas, and you had to figure out which one was which? Could you do that? Right? Could you do that? I mean, if I gave the equations in Vertex form, you should be able to do that pretty easily, right? If I didn't give them in Vertex form, that's kind of a nasty question, because you'd have to figure out the Vertex form of 4 different parabolas. Or maybe I can just do it with 2. Maybe I could have 2 graphs that are the same, and you actually have to sort through the transformations by graphing idea to see which one's which, right? So I wouldn't assume that the one on the test is exactly the same as easiness as this, but it should be in the same flavor. I mean, there should at least be some of the question you can still get by just this surface level pattern matching. Most of you got a lot of this right, okay? I will do my best to actually give you the honest to goodness graphs that match these equations on the test, so that you can actually plug in points and check, right? Because that's another thing you could do to just check things, right? This one, for example, I could say, okay, this is definitely, all right, so this is 10 units, right? So this is -2. So whatever this function is, if I put in -1, it should be really close to -2. Excuse me, if I put in -2, it should be really close to -1, right? And I could try plugging in, -2 into these various functions and see which one actually comes out to -2. And I think, well, there's 2 of them that are kind of close to -2-ish. Actually, this one is giving us -2 at -2, isn't it? And that one's giving us -2 at -2. So if I plugged in -2 into these formulas, I could pin down which 2 of these have to match these 2. You could play games like that. But anyway, if you were playing those kinds of games on the quiz, you had gotten confused, right? Because I had a mistake in this graph. I won't make this mistake on the test, all right? So. All right. Problem 2. So this is something we can all get if I put this question on the test, like everybody should be able to get this, all right? A lot of you haven't yet, right? So you got work to do. But here's the deal. So if we have x squared minus 8x plus 11, what we can do is we complete the square on this, right? So I take half of 8, rather half of minus 8, which is minus 4. I add that to x, I square it. Then completing the square says, if I FOIL this out, I've added 16, right? So I have to subtract 16 to be fair. So there you go, that's completing the square. Now, I clean it up, I get minus 5. Once you get minus 5, at this point, you have the format, the vertex format, right? What's the vertex format for parabola, remember? Y a times x minus h squared plus k, right? So if you have that pattern, you can compare that pattern to what you have and read from it h and k. So I look at this, I look at that, and I see, aha, h is equal to 4, k is equal to minus 5, right? There is an asymmetry, right, between the way h appears in the formula and the way k appears in the formula. You don't try to think through a minus for the k. You just read k right off that, you know? You do have to flip signs on the number that appears here, just like we do with the factor theorem, right? If you have f of 3 equals to 0, that means that x minus 3 is a factor, right? Same kind of thing here. But anyway, a lot of you put like minus 4 comma minus 5 here, all right? See the error? It has to be 4 comma minus 5. Conceptually, when you plug 4 into this formula, that's the smallest it can give you, because that's where the vertex is, right? If I plug 4 into this formula, 4 minus 4 is 0, so I get minus 5. That is the smallest value the parabola takes. That's the vertex. That's where it turns around, all right? Anyway, so there's the vertex. And then anytime you have completing the square and you get a minus, then we can factor. Because we can look at this as a squared minus b squared, where b is equal to the square root of 5. And then we get a plus b and a minus b, which then shows me x-intercepts at 4 minus root 5 and 4 plus root 5. And I didn't expect you to put this down here. That's just so I can make sure I don't look past somebody who did things numerically. Okay? Any questions? Yeah?
Can this answer also be arrived at using the h and k formulas?
It can, but you got to be careful. A lot of people who tried to use the h and k formulas, for whatever reason, got wrong things. Hopefully it's not that I wrote wrong h and k formulas. Somebody had a k formula that didn't have a square in it, which was not right. The k formula definitely has a like a b squared, I think, in it. And I don't remember the formula right off the top of my head, but yeah, you could use those formulas. But this is much, much faster, right? What would be really smart is to use both the HK formulas and this, right, and double check yourself. Problem 3, again, I would say, if you got this problem wrong, you can get this problem right on the test, right? There's nothing stopping you. This is a problem we should all be able to get right, right? Don't think of this as a problem that's so hard you can't do it, because it is a problem that you can do, right? So, and most everybody didn't get hung up on the factoring here, right? So we have x plus 2, x minus 2, and then downstairs we had x plus 1 times x minus 2, right? So if you look at it, numbers that make either the denominator or the numerator of this fraction 0 are respectively minus 2, minus 1, and 2. I know that 2 is a hole in the graph because there's an x minus 2 above and below, right? Same order, that makes it a hole. Okay? I know that minus 1, there's a vertical asymptote there because I've got this x plus 1 downstairs, and I don't have any compensating x plus 1 in the numerator, right? So it's just a plain old vertical asymptote. And minus 2 is an x-intercept because I've got an x plus 2 up here, and there's no compensating, balancing x plus 2 downstairs to like undo it, you know? So to find out where the hole in the graph is, I look at the reduced function, which basically I just cancel out the corresponding factor to the hole, x minus 2. It leaves me x plus 2 over x plus 1. And you take that, you plug in 2, and you get 4/3. So the hole in the graph is actually at 2 comma 4/3. The vertical asymptote is x equals minus 1, and the x-intercept is at minus 2, 0. Now, I did not take points off, you guys, if you just wrote minus 2, minus 1, and 2 here, right? That wouldn't have been wrong. It's not the best answer, though, right? Because, okay, the wording here, I said fill in the blanks below. I didn't really clarify. I want the coordinates. I want the best description of these different features, right? So like the best description of the x-intercept is that here's the coordinate where it's at, right? But I wouldn't count it. I would not count you wrong here if you just wrote minus 2. Now, if you wrote minus 2, minus 1, and 2 here, I don't know what to do with that, right? That's, you've given me the right answer, but you give me 2 wrong answers too, right? So what am I to do? And so some of you did that kind of thing on any one of these. You gave me like more things than there are there. So I don't know what to do with that. I mean, you're right, but you're also wrong. I mean, how do I, something has to be said there. And like here, I didn't take points off if you didn't write x equals minus 1, but I might have written under this, hey, x equals minus 1, right? The way we understand the equation, or how we describe a hole in a vertical asymptote is different than how we describe like a hole in the graph or a x-intercept, right? Because x-intercept or hole in the graph happens at a point, right? Whereas the vertical asymptote, we need an equation to describe because it's all points on that vertical line, right? But anyway, again, I wouldn't take points off if you just wrote minus 2, minus 1, and 2 here. However, if I change the wording for this problem and I said fill in the blanks below for this, please give coordinates for any x-intercepts or holes in the graph and equations for any vertical asymptotes as appropriate, then I would want you to write this, this, and this for those answers, right? But unless I give a little bit more fine-tuned instruction here, I don't feel right to take points off, yeah? So. Well, that was a sneeze. Did you guys hear that? There's another room. I heard a sneeze. Powerful sneeze. I feel like that might have been Dr. Sprano. I know that sneeze. All right, anyway. This problem is easier than you think, if you got it wrong. So 3f of 2. So that means 3 times f of 2 by definition, all right? What is f of 2? Well, you got a graph over here, y equals f of x, right? So you look at 2, come up to here. That point right there on the graph tells you that f of 2 equals to 2. I plug that in here. I get 3 times 2, which is 6. All there is to it. Now, a lot of you got that right, which is great. fg of minus 1 for part B here. This is the product of f and g. So I have f of minus 1 times g of minus 1. Now, f of minus 1 I can find from the graph. Here's minus 1. F of minus 1 is 0. G of minus 1, I have to plug this minus 1 up into this formula up here. So I get 3 times minus 1 squared minus 3, which is 3 minus 3, which is 0. So any way you slice it, I get 0, I get 0, I get 0 times 0 is 0, There's lots of ways to get part B right, So the answer is 0 there. C is by far the most tricky part in this problem because it involves composition. F composed with g of 1, by definition, is f of g of 1. So this one, you can't just multiply or divide values of the two functions at 1. That's not how it works. Function composition has to go inside out. So inside we have g of 1. G of 1, plug it in up in here, we get 3 times 1 squared minus 3, so g of 1 is 0 again. Right? G of 1 is 3 minus 3. So we have f of 0. What is f of 0? Well, go back to my graph. F of 0 is 1. So the answer is 1. Yeah. Why is it f of 3 minus 3? Because g of 1. So the real question is, why is g of 1 3 minus 3, right? So g of 1 is 3 times 1 squared minus 3, which is 3 minus 3, which is 0. That's why that's there. Because we're looking at f composed with g. So the g of 1 means I have to evaluate the formula for g at 1. Right? And so that gives me 3 minus 3. It's a funny thing, right? That the g function, it behaves the same at 1 and minus 1, right? That's because g is actually an example of an even function, So, hey, I didn't test even or odd on this quiz. What the what? Hey. Oh, man. There was no testing of Okay. That's the first time I've said this in any review session, so I guess it'll have to just stay there. We'll get back to testing even and odd on test 3 probably. I think it's a little late for me to emphasize it at this point. You have had some of that in the homework though, haven't you? Even, odd, yeah. Well, if I put an even and odd question on the test, I will email you guys, okay? And by email, I mean I'll post an announcement in Canvas, which hopefully you'll see. But, okay, anyway, any questions about problem 4? Let's go on, yeah? Problem 5? So I tried to make life a little bit easier for you guys in the sense that I didn't put a hole in the graph on this problem. I kept it on the other problem. I wanted to test you guys on the hole in the graph idea because we did talk about it a fair amount in here, right? But I also didn't want to give you one problem which had absolutely everything in it, like some of my examples in class, you know? And so I was trying to make it easier overall by putting the hole in the other page and no hole here. So this is nice because the critical numbers, -2, -6, and 4, they're, you know, they're all just appearing in either the numerator or the denominator, right? So there's no holes in the graph. We're just facing either vertical asymptotes at -6 and 4 because we got division by 0 there, right? Or an x-intercept at -2 because we've got 0 in the numerator, right? And then I plugged in f of 6 just to get started. If I plug in 6, I get this, which is less than 0, which puts minuses over here. 4, there's just one copy of x minus 4, right? So I flip signs. And then, interestingly, at -2, we've got 2 copies of x plus 2, right? So we bounce there. Stay plus. And then at -6, we've just got one x minus x plus 6 up here, so we flip from plus to minus like that, all right? Like I said here, my graph does not include attention to detail about the y-intercept, but you could add that to be more precise. I plugged in the I plugged in 0 into another class. I think it's 1/3. So my graph isn't quite right. Like, if I remember right, this is supposed to pass at like 1/3. So my you know, it's me. Now the one thing here that we should address here before we make the graph is that you notice that we have degree 2 upstairs and degree 2 downstairs, right? So that means that there's going to be a horizontal asymptote which isn't 0, right? A horizontal asymptote 0 if the denominator has larger degree than the numerator, right? But here we have equal degree, so we could use the theorem that we take the ratio of the leading coefficients, which are -2 and 1 respectively, so I got a horizontal asymptote of -2. The other way you could have found this, yeah?
So why would you take f of 6?
Oh, that's just to get something over here. There's no reason. You could have put 7 in there, or 5, just the same. I mean, I should probably just put 5. That would have made it easier, right? But no reason, really. Just a test point over here. I did it because I didn't want to trick myself. I don't usually have a minus out front, so you know, that minus might flip it might flip it over from what it usually is, yeah? A lot of my examples. So what's the other way you could have found this -2 here, guys? Some of you did it. You do what? You take this and divide by that, right? Do long division. And if you did the long division here, you'd get -2 for the thing on top of the division, and then the remainder would be some linear term. So you could also do long division to find this -2 if you wanted to do it that way. Anyway, after you have all that, you got your horizontal asymptote at -2. You have vertical asymptotes at -6 and 4. You got to bounce at 2, at -2, right? And you got this sign chart, so it forces you pretty much to draw this picture, right? And just to explain what happened, when I was grading this problem, I don't remember which section it is I was grading, but whatever section I was grading, I had about like 10 problems in it. There were just 10 people who just, in a row, that just had it just really, really wrong, like very wrong. And then I turned the page, and the next, I grade problem by problem, right? So I just grade one problem at a time, typically, or one page, sometimes, depending on how much. I only have so much RAM, you know? So whatever fits in my RAM. And then, so I was grading this problem over and over again, and just, it was wrong. And then another solution, still wrong. And then another solution, still wrong. And then another solution, still wrong. And after about the 10th one of these, I was like, ah, why? Surely someone understands. And then I turned the page, and there was a perfect solution. I mean, well, this isn't perfect either, right? But it looked close to what I have. I was like, oh, finally. And when that kind of thing happens, I add bonus points. That's what I do. So I said +2. So it is possible that you got like +1 or +2 on this. That just means that you've done a good job and it's neat and it helped me feel better about my day. But listen, there is really, okay, I say everybody can, I did say everybody can get on page 1, right? The problem 2 and problem 3, and I do believe that. I understand there's a lot more moving pieces here, so it's going to be harder for everybody to get totally on board here, but you can at least get some of the things right for sure, right? Like everybody can get on board with the vertical asymptotes, right? We can all get that, right? And we can at least all get the sign chart right, you know? And once you have the vertical asymptotes and the sign chart right, you've got a shot of at least getting the shape generally right, right? Make sure you don't cross the x-axis where you don't have a critical point, right? Because you can only cross the x-axis or touch the x-axis where you've got critical numbers. That's a good guide, right? And then think about your horizontal asymptote, right? The horizontal asymptote's usually 0, but if it's not 0, it's just going to be the ratio of the leading coefficients, right? Because I'm not going to put you graphing an oblique asymptote or a parabolic asymptote on the test because I'm not an idiot. Well, I'm an idiot, but not that much of an idiot, let's say. You had a question?
Oh, no, I think I answered it.
Oh, okay. All right. And I wouldn't assume that the graphing problem on the test looks exactly like this. It's not this particular problem I want to test on. It's the concepts and skills that I'm testing on, right? So it might well be that I have like a different kind of pattern than this. Don't assume that it's this pattern. It might not be this pattern, all right? When I say that the quiz is a pretest, what I mean is that I'm sort of tipping you, I'm showing you my hand, I'm showing you the part of the material that I think is most reasonably tested. And so when I test any class in college, it's a university class, I try to test concepts, not specific problems, as much as I can. Now, that's not entirely true here. There is a very high likelihood that you'll have problems that are very much like the ones I gave on quiz 2. That is also true. But it's not universally true, so I have to qualify that a little bit. So here, I told the other class that I could tell that they've been cheating on me on this problem. I could see evidence that they'd done math with another. I saw synthetic division. There was synthetic division. I saw it here. Yeah.
Synthetic division is actually pretty easy to understand.
How dare you? Yes, no, if you want to learn synthetic division, go ahead. But I will say, of all the people who tried to use synthetic division for this, and there were probably about 10 or 20, I had one get it right, I think, all the way through. So yes, it is, it is doable, but see here, anyway, let me just get to it. So I tell you evaluate f of 1 and f of 2. F of 1, if we plug it in, what do we get? We get 1 minus 6 plus 11 minus 6, which is 0, right? If we plug in 2, we get 2 cubed, which is 8, 6 times 2 squared, which is 4, so 6 times 4 is 24, and then 2 times 11, 22. So if you look at it, we've got 8 minus 24 plus 22 minus 6 is 0. So both 1 and 2 give you 0. Now some of you plugged in 2 and didn't get 0, and that is unfortunate. All right, but actually it still shouldn't have mattered because you could still, think about this, guys. If you found either one of these was 0 correctly, you should have been able to divide out the other one, right? What happens after you divide one power out? Really, I don't have to give you two things here. If I just gave you one thing, that would have been enough. See, if I just gave you f of 1 was 0, you could have divided by x minus 1. What you would have been left with is what? A quadratic. Can you factor a quadratic? The answer is yes, you can factor any quadratic because you know completing the square, right? So there is no quadratic which you cannot factor. And in fact, if you had factored out x minus 1, you would have been left with this, which would have been actually pretty easy to factor for this problem. So if you either got one of these or the other of these evaluating to 0, you should have known from the factor theorem that respectively x minus 1 or x minus 2 is a factor, right? Now what I intended was for you to get both of these as a factor, and then you multiply them, which gives you that's a factor, right? And then if we divide x squared minus 3x plus 2 into this cubic, then out pops x minus 3, right, when we do the long division. Now if you do like synthetic division, which, you know, anyway, if you do, you'd have to do 2 synthetic divisions to get to this, yeah? One for the 1 and one for the 2. But anyway, you get x minus 3 here, which means that we have this, since the remainder is 0, we have this factoring, yeah? And then, of course, this was x minus 1 times x minus 2, so there you go, completely factored. We'll work another one of these once we're past the review and once we're past the solution. Okay, so let me just go on. Any questions, though? Or? So we spent a while talking about complex zeros, but many of you still haven't quite got it. But here it is. Again, if we have f of 1 plus 2i is 0, complex zeros theorem says that means that there's an x minus 1 squared plus 4 prime factor of f of x. And when I multiply that out, I've got x squared minus 2x plus 5. So now, any questions about that? No? All right, but I also know that f of 5 is 0, right? So that tells me that there's an x minus 5 factor. And so I don't even need to do any kind of, well, I don't have a formula for f of x, right? I'm trying to build it. I know that it's cubic, right? Which means it's third order. So what do I know? I know that there's this quadratic factor. I know that there's this linear factor. But the thing is, if you take a quadratic times a linear, that's already third order. So that's all we need. There's no more, right? Except what? Except there's always this possibility of multiplying the polynomial by some number, right? None of the information we have so far fixes the leading coefficient. So we have to put an a in there to account for that. So I have a times x minus 5 times that. But what else do I know? I know that f of 0 is 50, right? So I can plug that in. F of 0, and f of 0 is what? It's minus 5 from this piece, and 5 from that piece. So I get a times minus 5 times 5, which is to say that a times minus 25 is 50, which if I solve for a, I get a is 50 over minus 25, which gives me minus 2. Then I plug that back up in here. Now, the annoying thing about this problem is these bold words right here, right? See these bold words? Standard form, right? So anytime you see me bold something in a problem, there's probably a reason for that. I'm trying to draw your attention to it. And so I may or may not have been successful there, but standard form, which means what? We have to collect like terms and multiply it out, right? So I multiply it out like that. There's my 6 terms from multiplying this out, this times that. And you know, guys, what I usually do when I multiply 2 things by 3 things, all I do is I multiply this x by this, this, and this. I write those first. See that x cubed minus 2x squared plus 5x. And then the last 3 terms, I multiply the minus 5. So minus 5x squared minus 5 times minus 2 is plus 10x. Minus 5 times plus 5 is the minus 25. That's how I multiply these things, right? So FOIL kind of breaks down there, right? Because, well, there's not 4 things, right? But anyway, then I distribute the minus 2 through here, collect like terms, right? So I've got minus 2 minus 5 is minus 7, and 5 plus 10 is 15. And so I get these, it collapses down to just these 4 terms. Then I multiply the minus 2 through, and I get that. And voila, it's in standard form, and there's your answer. Now, if I ask this question again on the test, I will give you more white space. Like, I'm not pleased with the amount of white space there was on this test for this problem. Like, there's not enough, it's cramped, right? Whenever this kind of thing happens, if you are working a problem and you feel cramped, it's perfectly acceptable to leave yourself a spot for the answer, right? and then say work on the back of the page and just draw an arrow or whatever. I always print tests out single-sided so that you can use the back of the previous page or this page, whatever, you know, to work out details if you want. Okay, so if you ever feel cramped, like use the back of a page. That's why part of the reason I print them out single-sided is for that reason. You know, I've seen other people who teach, especially remedial algebra, manage to put like 25 problems on 2 pages, and they're like double column format, and there's like these little, no, like there should be space for students to show their work on the problems, you know. So I try to give you workplace, but some of you guys write pretty big too, so there's that working against me. Anyway, problem 8. Actually, I think one of the things that's working against you guys in math, generally speaking, I was thinking about this the other day, you don't write anymore. How many of you guys write anything in your other classes? Like, maybe you take notes? Do you actually take notes in other classes, like a lot of them? So you do? You do? That's good. So I think there's a growing subpopulation of people who just do everything with a tablet, just like either typing or just taking pictures, right? And many people are not writing a lot. They're not gaining the manual dexterity they need to actually write down steps for an hour. There is a significant decrease in the like stamina of people to take math tests I've seen over the last decade or so. It's been a gradual. I think it has a lot to do with smartphones, honestly. But anyway, it's really more a question of attention span than the handwriting issue. But anyway, this one. So I'll stop giving my get off my lawn speech here. So f of 0 is minus 48. I'm given that, right? So I tell you actually that that's at minus 48. Lovely. And then we say find the polynomial of least degree with the graph below. All right. So what do we want? So like, oh, by the way, like largely speaking, I think almost all of the people who took this test had something right here. Like a lot of people at least have some kernel of truth in their answer here, and so there's hope. Because almost everybody has an x plus 6, an x plus 2, and an x minus 4 in their answer. But then the problem is a lot of you have gotten carried away with the bouncing. Like I see a lot of people putting a square on this one, and that one, right? But the thing is there's no bounce at minus 6, there's no bounce at 4, right? Those are crossings. So you just want one copy of x plus 6 and one copy of x minus 4 because it crosses there and there, right? There's a bounce at 2, minus 2 rather. That's why I need this square here. So this, the lowest order you can achieve such a shape is order 4. And that's what my formula is. 1 plus 2 plus 1 is 4, order 4. Now f of 0 is minus 48, so I plug it in, and I get minus 40. Well, this gives me minus 96, so I get minus 48 divided by minus 96, which is also known as a half. And there you go. That's the formula. Any question about this? So some of the other review sessions, the students have asked me, like, could you have this kind of problem, but like with a rational function? And like, yeah, we could also have this kind of problem with a rational function. So we worked some of those kind of problems in the other review sessions. You know, like how would you fit, if you had a picture with the vertical asymptote and different kinds of x-intercepts, you know, could you build the rational function that also looks like the graph? Right? That's another kind of problem. We can talk about that after I put this away. Actually, after I put this away, we can talk about whatever you want. It's up to you guys, really. So here, we have x to the 5th plus 11x cubed plus 2x squared minus 10. The question is, does it have a factor? G of x equals x cubed plus 2. So I said calculate f of x over g of x via long division of polynomials and answer the question. We have to do long division here. Like synthetic division is not even an option because in order to do synthetic division, you have to have a divisor which is linear. It's just something of the form x plus c, right? Or x minus c, I should say. And that's not the case here. So in order to do synthetic division, you'd first have to factor x cubed plus 2. And you can do that. X cubed plus 2 does factor. It factors into x plus the cube root of 2. times x minus a complex factor times x minus the conjugate of that complex factor. So there are 3 zeros of this, one of which is real, 2 of which is complex. To do synthetic division on this problem, you'd have to do 3 synthetic divisions, 1 real, and 2 pairs of complex synthetic divisions. Like, definitely you don't want to do synthetic division on this problem, all right? Anyway, here's the long division. So we're dividing x cubed plus 2 into this. So how do I get 3x to the 5th? Well, I need 3x squared up here, right? Because 3x squared times x cubed gives me 3x to the 5th. 3x squared times 2 gives me the 6x squared over here, right? Then I subtract. I get 11x cubed. 2 minus 6 is minus 4, and bring down the minus 10. Now I need to get this 11x cubed. How do I get 11x cubed from this as a multiple? Well, I need to multiply by 11, right? So 11 times x cubed gives me the 11x cubed. 11 times 2 gives me 22. I subtract again. The 11x cubes cancel. And I'm left with minus 4x squared minus 32. We're done, because this has degree 2, whereas my divisor has degree 3. Once your last remainder has smaller degree than your divisor, you're done. And so if the last non-zero remainder is not 0, that means it does not factor. Simple as that. And the equation that corresponds to this is f of x over g of x is 3x squared plus 11 minus parentheses, minus this fraction 4x squared plus 32 over x cubed plus 2. If you take what's in the box and you multiply by x cubed plus 2, you get this down here, right? And so basically what happens is if you try to factor out x cubed plus 2, you can kind of do it this much. You can find a 3x squared plus 11 worth of x cubed plus 2 sitting inside f of x, but what's left over, there's a leftover piece, right? There's this piece over here, and so like when you try to factor, it just doesn't work out because you're forced to add this other piece over here. That's how I think about it, but you can just stop here. Non-zero remainder does not factor. So there are 2 aspects to this question. The one is answer the question. Some of you have done the long division correctly, but you have not answered the question. In that case, I took off 1 point. If you've answered the question correctly, but your long division is far from correct, I've taken off 2 points. So that's pretty much it for this. Any questions? So a reminder, you only have 30 points in your syllabus for this quiz, but I did give you 40 points to earn, right? So if you got a 40 on this, you've earned 10 bonus points. Somebody somewhere in some section earned a 41, but that's like a singular event. I think I had some scores in the high 30s, but you know, probably only about 10% of the class had like above 30. Most everybody else has below 30. And I have scores ranging from 7, from all the way, like I said, ranging from about 7 all the way up to 41. A lot of people in the 20s. So let's see here. And here, yeah, I see 20s, I see teens, I see some 30s, you know. There's diversity in scores in here for sure. Any questions? So, no? Let me put this away.
Is the test going to be the same number of questions?
I think the test is likely to be 3 pages too. If it's the same number of questions or not, I'm not sure about that, but I'll probably try to stick to 3 pages. I dream of making a 2-page test, but at some point if I make it too short, then I don't get an accurate picture of what you know. You know? I don't think anyone is really starving for time with 3 pages, right? No. So let's see. So other sections, I've done some more review of completing the square because it seems like people are still not quite with completing the square. Let's do another one of those, yeah? How about this? X squared plus 10x plus 200. This one's kind of nice. So let's find the vertex of this parabola by completing the square, and let's determine if there are any x-intercepts, and if there are not any x-intercepts, let's factor it over the complex numbers. All right, let's do all those things. So how do you complete the square here? What do you do? X plus what squared should I do? Nobody? X plus 5? All right. Oh, my bad. I was trying to make this problem easier, but I'll just deal with it. X plus 5 squared, yeah. And then what? Minus, I have to subtract 25 then. And I've got plus 200. All right, so that gives us what? We've got x plus 5 squared plus 175. Okay, so at this point, I can tell you a few things, right? Number one, the polynomial is prime, right? It's a prime polynomial. You cannot factor this over the reals, right? So prime does not factor over the reals, and also has vertex what? What's the vertex here?
-5, 175.
-5, 175. Very good. All right. Now, we haven't done this a lot, but it's something we should know how to do. Can you factor this over the complex numbers? What does this look like in terms of complex? Well, you can look at this as x plus 5 squared, right? Minus I times the square root of 175, quantity squared. This is a sneaky step. Let me try to explain it to you. So if I can make this look like, the idea is we want to see it as a squared minus b squared, right? Because that's a plus b times a minus b. So if we can see the thing up here, right? If we can see this as a squared minus b squared, then we can factor it. So what I'm saying then is to see that pattern, we have to have minus b squared equals to 175. But what does that tell you? You can think through it. That means that b squared is minus 175, which is to say that b is equal to plus or minus the square root of minus 175, which is plus or minus I root 175. And so you just pick the plus and do that. The bottom line is what I wrote there is an identity. Like if you multiply this out, you get back up to that because I squared is minus 1. Now once we have that, you can factor this using, the difference of squares idea. So x plus 5 plus I root 175, x plus 5 minus I root 175. And there it is. This is how the quadratic, how the factors factored over the complex numbers. All right. So any prime quadratic will factor over the complex numbers because we can always change plus a number to minus a number squared with an I on it, like imaginary number squared like that. Let me do another one of these really quick. If you had x squared plus 4x plus 5, you'd have x plus 2 squared minus 4 plus 5, which would be x plus 2 squared plus 1. This one's going to be easier for us to see. I know the 175 thing is like distracting for the previous example. So this would give us x plus 2 squared. 1 I can rewrite as minus I squared. Right? 1 is minus I squared. And so then you've got the difference of squares. So you can factor that as x plus 2 plus I, x plus 2 minus I. So if you look back at your notes, when we talked about the complex zeros, we had a complex zero theorem, and in there I told you if you have a complex zero, it always factors as what? What was the theorem? Let me just write it up here. F of alpha plus I beta equal to 0. That's going to be the case if and only if what? If x minus alpha squared plus beta squared factors f of x, which is also going to be true if and only if like f of x is equal to, you know, x minus alpha plus I beta, x minus alpha minus I beta, and times something else. But
And what's alpha and beta supposed to represent?
the real and imaginary parts of the zero. So like, depends on the problem, but for this one, for the second example here, we ended up with alpha equals to -2 and beta equals to 1. The first one I worked today, what's alpha and beta? Can you guys tell me? Yeah, here alpha, yeah, -5, and beta is, there are two reasonable things to say for, yes, it's either square root of 175 or minus the square root of 175. Either way you could go. Like you can always, if you have, the thing is, if you have alpha, f of alpha plus I beta equal to 0, that's also true only if the alpha minus I beta is also equal to 0. So you always have your choice of like plus or minus for the beta piece. Anyway, these are, you know, what I'm trying to say is, technically speaking, if you just have on your formula sheet the complex zero theorem, you don't have to really think through this right here. You could just, like, you know, use the theorem, say, oh, well, if I've got this, it factors to that. Because that's alpha equals to -5 and beta equals to square root of 175. So I could just follow the theorem if this doesn't excite you. Anyway, enough about all this. Let's get back to the, you know, more important part. I guess one of the more important parts here would be graph, right? What would the graph look like for which, you know, your choice. Which one do you want to graph? This one or that one? Example 1 or example 2? Which is your preference for the graph here? Two? All right. So where's the vertex for 2? The vertex is at -2, 1. Right? So -2, 1. So about here. And where's the y-intercept for 2? Remember, the graph has to be symmetric about the vertex, right? The y-intercept, what's the y-intercept of this one? 5, right? At 5. See that from here, right here? The original formula, plug in 0, you get 5. So if we look at that, we've got something like this, right? And then you can just mirror that on the other side of the vertex. Roughly speaking, there you go. Y equals to x squared plus 4x plus 5. So what does it mean when the quadratic has a complex factorization in terms of the geometry of the problem? It simply means this: there's no x-intercepts, right? Complex factoring corresponds to the case that the vertex is either above the x-axis, so it opens up and never hits the x-axis. There's no place where the polynomial is 0, right? On the other hand, you could have a quadratic which has got a vertex below the x-axis and opens down. That also could have a complex factorization because there's no x-intercept. X-intercepts don't have to be pretty, right? They don't have to be pretty at all. Like, here's one. We could have y equals to, let's say, 2x squared plus 4x minus, I don't know, 7. Let's not do 7. 7's ugly. 7's too ugly. Minus 20 there. I think that'll do it for us. Suppose you want to graph that thing. Well, I mean, let's find the vertex. Let's find the x-intercepts for that one. How would you do it? Forgot to zoom back in. You guys are here, right? I think we had most of it on the board. All right, so here we go. So this one, we haven't done this as much, but completing the square here requires some pre-processing, right? First thing we have to do is factor that 2 out before we can do much, right? So factor 2 out. We've got 2 times x squared plus 2x minus 10, right? Now once I've done that, now I can complete the square. So how would you, what's completing the square look like here? X plus what quantity squared? So what do I put there in the parentheses? Plus 1? Yeah, plus 1 quantity squared. And then I have to subtract 1 to be fair, because 1 squared is 1. And I still have the minus 10. So let's clean things up here. That's 2 times x plus 1 squared minus 11. So what's the vertex? Minus 1 minus 11 would be incorrect. It was a trap. So this is the reason I was doing this, is because I want you to be aware of this issue. This is not vertex form yet, right? Vertex form is this. Notice that the k is out here on its lonesome. But 2 is here, right? So we have to multiply this out to get to the vertex form. So you're almost right. It's just that the vertex is where minus 1 comma minus 22, right? That's where the vertex is. Something to think about, if you take the graph of a parabola, right, and you multiply it by a number, you vertically stretch the parabola, what does it do? It leaves the vertex at the same x value, right? H doesn't change. But when you stretch the graph out, you move the vertex up or down, depending on whether this thing you're multiplying by is bigger than 1 or less than 1, right? Like if your vertex was originally at y equals to 2, and you multiply the parabola by a half, it moves the vertex to 1. If you take the parabola as formula and you multiply it by 2, you would take this vertex here at 2 and move it up to 4. So when we have 2 out here, it doesn't affect the h part and the k part in the same way. Like there's an asymmetry between h and k. Anyway, bottom line, multiply it out like this to see the vertex. And then what were the x-intercepts? To see x-intercepts, I'm going to undo what I just did and go back up to here. And we've got 2 times what? So you have x plus 1 squared minus 11, which getting to the point here, we can factor as x plus 1 plus the square root of 11 times x plus 1 minus the square root of 11. So here I'm making a mental adjustment here. This 11, right? 11 I'm thinking of as the square root of 11 squared here. So then I've got a squared minus b squared pattern, which gives me a plus b times a minus b again. Anyway, the point here is simply this. If you complete the square, you've got minus a number. You can factor by taking plus the square root of that number and then minus the square root of number in this pattern, right? So what are my x-intercepts? Minus 1. So we get minus 1 minus the square root of 11 comma 0 and minus 1 plus the square root of 11 comma 0. Those are your x-intercepts. And the graph, the graph. Not sure I really want to graph this thing. I think everything, most of the interesting stuff here is happening way negative. The vertex is at like minus 1, minus 22. What is square root of 11 is what? It's about 3.2 or something. I don't know. 3.4 maybe. So that's like minus 4.4. So I think the x-intercepts are roughly speaking here and here, and something looks kind of sort of like this. Now that's very crude here on my part. But I want to kind of go on from this example to other things. The most important point here is that the graph crosses the x-axis, right? Because we do have x-intercepts for this example, because when we complete the square, we don't end up with a plus, the square plus something. We end up with the square minus something, which means that we can factor over the real numbers, like this, yeah. Not pretty, but there it is, yeah. Losing my money. Let's see here. Ah, my eraser shirt needs a wash. All right, let's try another example out over here. Suppose you have f of x equal to x cubed. Let's say 3x cubed minus 2x squared plus 10x minus 11. Factor f of x completely. Hint. Try x equals to 1. All right. Let's do it. So what happens? What happens when we plug x equals to 1 into that? What do you guys get? Let's see here, f of 1 is 3 minus 2 plus 10 minus 11, which is what? 13. That's 13 minus 13, right? That's 0. What does this mean? So therefore what? Therefore, x minus 1 is factor, right? It's a factor of f of x. Can you factor x minus 1 out of that? I mean, personally, just by looking at it, I think it's kind of tough. But what if we divide it into there, right? So we've got 3x cubed minus 2x squared plus 10x minus 11. And we want to divide x minus 1 into that, because then that will help us factor, right? That'll help us find the, let's say, the cofactor to x minus 1. So my long division, what do I start with? How do I get a 3x cubed from an x minus 1? What do I want here? 3x squared. I think we got it. Yeah, 3x squared sounds like a good idea. So that gives me 3x cubed minus 3x squared. I got to subtract those. What's that leave me with? That leaves me with, looks like x squared, yeah? Plus 10x minus 11. How do I get an x squared from x minus 1? Well, I think I just need an x, right? So plus x. So that gives me x squared minus x. I got to subtract those. So when I do that, that gets me a 9x